So we've looked at the Cauchy-Riemann conditions in Cartesian coordinates, but sometimes it's helpful to look at these problems, at these complex number problems in terms of polar coordinates. So let's look at what those same conditions are in polar coordinates. So really quick, let's just write down what they are in Cartesian coordinates so we can see how they compare. Okay, so in Cartesian coordinates, we said that we have some complex variable z that was defined as x plus I y. And then we could have a complex function f of z that had a real component that was a function of z plus an imaginary component that could also be a function of z. Okay, and we found that the Cauchy-Riemann conditions then are that the partial of the real with respect to x must be equal to the partial of the imaginary with respect to y, and the partial of the real with respect to y have to be equal to the negative of the partial of the imaginary with respect to x. Okay, so those were the Cauchy-Riemann conditions in Cartesian coordinates. And so now let's look at what they are in polar coordinates. Okay, so in Cartesian coordinates, we have this complex variable z. In polar coordinates, we write that in terms of r and theta, and that is defined as re to the I theta. Okay, so that's our complex variable. So we can use re to the I theta instead of the x and y components like we would have over here. And of course, those are related. R cosine theta is the x value, r sine theta is the y value, and these are our normal transformations between Cartesian and polar coordinates. Okay, so then our function f of z, and I'm going to say f of re to the I theta, can have a real component. So we'd have a real component to that function that could be a function of r and theta, and then an imaginary component. So here's our imaginary component of that function that can also be a function of r and theta. And the Cauchy-Riemann conditions then, with those definitions, are that the partial of the real with respect to r has to be equal to 1 over r, the partial of the imaginary component with respect to theta, and that the partial of the imaginary with respect to r must be equal to negative 1 over r partial of the real with respect to theta. Okay, so like I said, sometimes these problems are better handled in polar coordinates. When we're working in the complex plane, sometimes they're easier in Cartesian coordinates. And so being able to transfer it into polar coordinates and then looking at the Cauchy-Riemann conditions in polar coordinates instead of Cartesian can sometimes be a bit more simple.